So today we're talking about Lewis dots. And Lewis dots, Lewis was one of the really great American scientists, not someone that was born overseas and worked in America, but he was actually born American. And he came up with the idea of of kind of depicting how atoms have electrons, share electrons. So really kind of introducing Lewis dot structures. Okay? If you remember back to electron configurations, for any energy level past the first one, the outermost electrons are the s and p's. The d's are not part of the outermost electrons because remember d's really start on the third energy level, but they're on the fourth row. So they're not really on the fourth row. You have 4s, 3d, 4p. So on the outermost energy, we have s's and p's. Okay, other than the first energy level. So because we have s's and p's, in the s energy level, we can hold 2 electrons, and in the p energy level, we can hold 6. So valence electrons are the outermost electrons in an atom. Valence electrons are the outermost electrons in an atom. And it happens that the outermost electrons are those that are involved in bonding. Okay? So there's kind of what's called the Octet Rule, and this is an important rule, and it applies to Lewis dot structures. And the Octet Rule essentially says that atoms want 8 electrons. We'll say want, and they really don't want or need anything because atoms aren't, they don't have emotions. So atoms want 8 electrons, since that is the most stable. And again, if we go back to electron configurations, noble gases have 8 electrons, and they're the most stable elements. So anyways, the Octet Rule applies to atoms wanting 8 electrons. And all we're going to do for this first one is we're just going to go across the second row of the periodic table. So we have lithium, and next to lithium we have beryllium, next to beryllium we have boron, and then we have carbon, and then we have nitrogen, oxygen, fluorine, and then eventually we have neon. So that's 8 elements. So our first element, again, has 1 electron in the second energy level. We call it 2s1. So what we're going to do is we're just going to put 1 dot there to symbolize that 1 electron around lithium. For beryllium, because it goes 2s1, 2s2, we're going to put 2 dots. We're going to actually put them in the same spot because they're in the same energy level. For boron, we're going to go 2s1, 2s2, and then on one of the sides, either top, right, or bottom, doesn't matter, we're going to have our first p, so 2p1. Carbon, we're going to go 1, 2, and then just like with the alpha hotel, we're going to put 1 in one orbital, 1 in another. With nitrogen, we're going to fill up the s, we're going to have p1, p2, p3. Then with oxygen, we're going to fill up the s, p1, p2, p3, and then we're going to double up one of these, so I'm just going to double up the bottom one. With fluorine, s2, p1, p2, p3, p4, p5, and then with neon, we've got S2, P1, P2, P3, P4, P5, P6. So anyways, as we go across, we're adding 1 electron, 1 outermost electron, and as we go across the row, we go from 1 to 8. Alright? And that is basically just a quick introduction to Lewis structures.